All right, everyone, get ready because today we're going deep into the world of AI and specifically how it can help us diagnose eye diseases. We're talking about building a CNN model that can actually look at images of retinas and tell us if there's a problem. Like,
Mhm.
it can diagnose diseases just from an image. And get this, we're working with a data set of over 80,000 retinal images. That's a lot of eyes.
Yeah, it's pretty amazing what deep learning can do these days. We're basically teaching a computer to see and understand these images, almost like training it to be an eye doctor.
Wow. Okay, so a computer playing eye doctor. That is both super cool and maybe a little bit scary. How do we even begin to teach a computer to do something that complex?
Well, it all starts with the data. Think of it like building a house, you got to have a good foundation first. In this case, our foundation is this huge data set of 80,000 retinal images.
Right. We mentioned earlier there are different categories of images, right?
Exactly. So the data set is divided into four categories: CNV, DME, and DRUSN. Those are all types of retinal diseases. And then we also have a category for images of normal, healthy retinas.
Okay, so like different textbooks to teach our AI student, right? One book for each type of disease and then one for what a healthy eye should look like.
That's a great way to put it. But before we start the teaching process, we got to make sure the learning materials are, well, easy to understand.
So are we talking like making sure the textbook has big letters and clear pictures?
Basically, yeah, we want the computer to focus on the important details in the image, nothing else. So there are a few things we do to prepare the images. First, we resize each image to 224 by 224 pixels.
So making sure all the textbooks are the same size?
Exactly. Then we convert the images to grayscale. That simplifies the color information, so it's easier for the computer to process. And finally, we normalize the pixel values. That just means we're making sure each image has the same brightness and contrast.
Makes sense. You don't want a faded, blurry textbook.
Right, exactly. So all these steps help to ensure the model isn't distracted by things that don't really matter, like slight variations in color or size. We really want it to focus on those key features that help diagnose the diseases.
Gotcha. So we've prepped the images. There are learning materials. Now, how about the brain? This is where we get to the CNN architecture design, right?
Yeah, that's the next step. CNN stands for Convolutional Neural Network, and it's specifically designed to work with images.
Okay, so it's kind of like building the brain of our AI eye doctor.
Yeah, you could say that. It's made up of layers of artificial neurons that can learn to recognize patterns in the images.
Whoa, hold on. So we're teaching a computer to actually see.
Pretty much. Obviously, it's not exactly the same as human vision, but it can learn to recognize visual features in a similar way. In our model, we use different types of layers to process the images. For example, we have convolutional layers. Those are kind of like the eyes of the model. They scan the images for specific features. Then we have max pooling layers, which help to simplify the information. It's like filtering out the noise and focusing on the most important details.
So not just seeing, but learning to pay attention to the right things.
Exactly. And then we have a flattening layer, which prepares the data for classification. And finally, a dense layer, which is like the decision-making part of the model. It takes all the information from the previous layers and assigns a probability to each of the four categories: the three diseases and the normal retina.
Wow, it really is like a whole team of specialists, each layer doing its part.
It's a lot more complex than those sci-fi movies make it seem, that's for sure. And, if you're interested in diving deeper into this, there's a great website called www.eranfit.net. They have some really good tutorials on computer vision and CNNs.
Oh, I'll have to check that out. So we prepped our images, the learning materials, and we've built the brain, the CNN architecture. Sounds like we're ready to send our AI to med school, right? It's time for the training process.
Yep, that's the next step. This is where we actually show the model our labeled images. So the model sees an image and we tell it, okay, this is a CNV or this is a normal retina and so on. The model goes through this process many times in rounds called epochs.
So like study sessions, basically. It looks at a bunch of images, tries to figure out what's what, and then we tell it if it's right or wrong.
Exactly. And with each epoch, it gets a little bit better at recognizing the different retinal conditions.
Cool.
We also use something called a batch size during training. Instead of showing the model one image at a time, we show it a batch of images, like 32 images at a time in this case.
Why do we do that?
It helps the model learn more efficiently.
Oh, okay.
And there are a couple of other terms you might come across during training: steps per epoch and validation steps.
What are those?
Well, steps per epoch basically tells us how many batches of images the model processes during each round of training.
So it's like tracking how many practice questions our AI student is answering in each study session.
Yeah, that's a good way to think about it.
Yeah.
And validation steps are similar, but they refer to the batches of images we use to check how well the model is doing on images it hasn't seen before.
Oh, so like a pop quiz to make sure it's actually learning, not just memorizing.
Right, exactly.
Right. Now, what about this early stopping thing?
Ah, yes. Early stopping is a technique we use to prevent overfitting.
What does that mean?
It means that we stop the training process if the model's performance on those validation images stops improving. We don't want it to just memorize the answers. We want it to actually understand the underlying concepts.
So if it's not getting any better at the pop quizzes, we know it's time to switch up the study plan.
Exactly.
Yeah.
We want our model to be a well-rounded eye doctor, not just someone who's good at one specific test.
Makes sense. Okay, so we've trained our model. Now it's time to see how well it actually performs, right? The final exam, model evaluation.
Yeah, that's the next step. And for that, we use metrics like accuracy and loss.
Accuracy, I get that. It's basically how often the model gets the diagnosis right.
Exactly. And loss tells us how far off the model is when it makes a mistake.
So we want high accuracy and low loss.
Right. And there are some really good ways to visualize these metrics. There's this great website, www.eranfit.net. They have some tutorials where they use graphs to show how the model's accuracy and loss change over time during training.
Cool. I like visuals. Makes things easier to understand. So let's say our model has good accuracy, especially on those unseen images. What happens then?
Well, then it's time to test it out on a completely new image, one it's never seen before.
Okay, the real test.
Exactly. But first, we have to prepare the image in the same way we did during preprocessing. Resizing, converting to grayscale, normalizing the pixel values, all that.
So making sure it's in the same format as the images the model learned from.
Right. We want to make sure the model can apply what it's learned to a brand new case.
This is exciting. Let's say we have a new image of a CNV retinal disease. What happens when we give it to the model?
The model analyzes the image, looking for those key features it's learned to recognize. Then, it gives us an output, which is basically a set of probabilities for each of the 4 categories.
So like how confident it is that the image belongs to each category.
Yeah, you could say that. And the category with the highest probability is the model's prediction or diagnosis.
Right. Drum roll, please. Did our AI eye doctor get it right?
It did. It correctly identified the image as CNV.
Whoa, that's amazing. So how does it actually tell us the diagnosis? Does it just print out CNV on the screen?
Well, the output itself is numerical, but we can easily translate that into a human-readable format. So yeah, it would display CNV.
Awesome. And can we make it even more visual, like actually show the diagnosis on the image itself?
Oh yeah, definitely. We can use a library like OpenCV to overlay the predicted text CNV right onto the original image.
Wow, that's so cool. It's like the AI is pointing out exactly what it's seeing. This is incredible. It really feels like we're on the verge of a new era of healthcare, where AI can help us diagnose diseases with amazing accuracy.
It's definitely an exciting time, but I think we should probably take a break here. And when we come back, we can talk more about what all this means for the future of healthcare.
Sounds good to me. All right, we're back. And I'm still thinking about that AI model, actually diagnosing an eye disease. Pretty wild. So where do we go from here? What does this mean for the future of healthcare? I mean, is this going to be in every doctor's office?
Well, it's hard to say for sure, but the potential is definitely huge. There are so many areas where this technology could make a real difference.
Like what? Give me some examples.
Well, one thing that comes to mind is eye screenings. Imagine if we could use AI to do routine eye screenings for everyone.
That would be amazing, especially for catching those diseases early on.
Exactly. Early detection is so important for retinal diseases. And with AI, we could potentially screen way more people than we can now and find those problems before they become serious.
Yeah, that makes sense. I mean, not everyone has easy access to an eye doctor.
Right. And that's another area where AI could be a game changer: telemedicine. Think about people in rural areas or places where there aren't enough specialists. They could take a picture of their retina, send it to an AI system, and get a diagnosis without even having to leave their home.
Wow, that would be incredible. Like democratizing healthcare, making it accessible to everyone.
Exactly.
Okay, but here's a question that's been bugging me. Are we talking about replacing doctors with computers?
That's a common concern, but I don't think that's the goal here. It's more about giving doctors a powerful new tool. The AI can do the initial screening, analyze tons of images really quickly, and flag anything that looks suspicious. Then the doctor can step in, review the results, and make the final diagnosis.
So it's more like a collaboration, a partnership.
Exactly.
That makes me feel better.
Oh, yeah.
I don't think anyone wants to be diagnosed by a robot.
I hear you.
But, okay, let's be real. There are always downsides to new technology. What are some things we need to be careful about with AI in healthcare?
Well, one big one is data privacy.
Yeah, that's a biggie.
We're talking about people's health information, which is incredibly sensitive. So we need to make absolutely sure that the data is being handled responsibly and securely.
No data breaches, no selling information to advertisers, none of that.
Exactly.
What about bias? I've heard that AI can sometimes be biased, like if it's trained on data that's not representative of everyone.
That's a really important point. The data we use to train these models has a huge impact on how they perform. So we need to make sure the data is diverse and inclusive so the AI can be accurate and fair for everyone.
Makes sense. This is a lot to think about.
It is. There are so many factors to consider when we're talking about AI in healthcare.
Like, it feels like we need a whole team of people working on this, not just the tech people, but doctors, ethicists, policymakers, everyone.
Absolutely. It's a complex issue.
So we got to be careful, but also, like, this is so exciting, right? I mean, the possibilities are pretty mind-blowing.
Oh, yeah, for sure. We're already seeing some amazing results with AI in other areas of healthcare, too, not just eye diseases, cancer detection, drug discovery. It's really incredible.
Okay, so before we get carried away with all the possibilities, let's bring it back to what we've been talking about today. We've walked through how to build a CNN model to diagnose retinal diseases. But where can people go to learn more about this? What if our listeners want to try this out themselves?
Well, there are a ton of resources online. For example, there's this great website called www.eranfit.net. They have some fantastic tutorials on computer vision and deep learning if you want to get into the technical stuff.
Right, Eran Fit, we mentioned his website earlier. Definitely check that out. What else would you recommend for people just starting to learn about this?
I would say stay curious, keep exploring. There are so many online courses, open source projects. It's easier than ever to get started. And don't be afraid to ask questions. The more we learn about this technology, the better we'll be able to use it responsibly.
That's great advice. I think that's a good place to wrap things up for this part. But when we come back, I want to talk about something else that's been on my mind, something a little more philosophical maybe. Like, what does it mean to be human in a world where AI is becoming so advanced? It's amazing to think we've gone from teaching computers to recognize cats and dogs in pictures to now they can diagnose diseases just by looking at an image. Like, it wasn't that long ago this stuff was science fiction.
It really is incredible how fast this field is moving.
But like we've been talking about, it's not just about the tech, it's about how we use it. We got to make sure we're using it responsibly.
Absolutely. We need to have those tough conversations about privacy, about bias, about making sure this technology benefits everyone.
And we got to be careful not to just blindly trust what the AI tells us, right? I
Yeah.
mean, it's a tool, it can be powerful, but it's not a replacement for human judgment.
Exactly. There are always going to be things that AI just can't understand, like the nuances of a patient's individual situation or their personal values and preferences.
That human touch is so important in healthcare. I think people want to know their doctor cares, you know.
Definitely. Empathy and compassion, those are things that AI can't really replicate.
So it's a balancing act, right? Embracing the power of AI, but also holding on to what makes us human.
I think that's a great way to put it.
Well, on that note, I want to thank you for joining me on this deep dive into the world of AI and eye health. It's been fascinating.
The pleasure was all mine.
And all our listeners out there, we hope you learned something new today. If you want to keep exploring this topic, definitely check out the resources we mentioned, like that website, www.eranfit.net. It's a great place to start. And remember, stay curious, keep asking questions, and let's keep the conversation going. Until next time, thanks for listening.